In the realm of industrial automation, the gradual transition to digital programmable logic controllers, or PLCs, marks a significant shift toward efficiency and connectivity. With a focus on data-driven decision-making and real-time control, digital PLCs epitomize the evolution of control systems in modern industries. Joining us today to delve into this topic are Ted Thayer, Principal Product Marketing Specialist for Control with Phoenix Contact, and Eric Kozikowsi, Lead Systems Integration Engineer at MXD. Let's explore the technical nuances of digital PLCs as well as their practical implications for industrial operations together. Thank you both for being here.
Thank you. My pleasure.
Thank you.
So before we decode the intricate mechanisms of digital PLCs, why don't each of you tell us a little bit about the company you represent as well as your role there? Ted, let's begin with you.
Yeah, Ted Thayer. I am the product marketing specialist for Control for Phoenix Contact. Phoenix Contact is an industrial automation manufacturer. They make everything from like your basic little wiring terminal blocks. We claim that we invented them actually back in the 20s, all the way up to IIoT devices that are implementing machine learning, artificial intelligence, web communications.
Yeah, my name is Eric Kozikowsi, and I'm a lead systems integration engineer at MXD. MXD is a public-private partnership under the Department of Defense. We work as a research institute trying to help U.S. manufacturers, focusing also on small to medium manufacturers to help get over the hurdles of implementing some of the Industry 4.0. So my role really deals a lot with how do we integrate older technology with newer software or hardware components, and overall the whole journey to getting to Industry 4.0.
So again, thank you both for being here. So let's do a general broad stroke right here. So why do you believe the industry is increasingly shifting toward the adoption of digital PLCs? Ted, if you want to take it first.
Yeah, well, I think there's a couple of factors coming into play. First of all, just the nature of the technology. There's definitely a push towards openness, open source coding, network connections. These factors that are playing in the whole adoption of Industry 4.0. And I just think that change in paradigm kind of necessitates a change in the hardware and the way that we do automation in the first place. So I think that's probably the biggest push towards it. And then honestly, as we're doing more and more complex systems, there's a desire to maybe simplify that, and part of that could be changing the form factor of a PLC, maybe if it's built into an Ethernet switch or, an HMI or something else like that, just simplifies the system, takes advantage of the computing power that we have available these days.
Yeah, I couldn't agree more. Really, nowadays it's about the flexibility and the integration piece. So, like Ted mentioned, having the PLCs been integrated with components like an HMI, shrinking down the form factor of electrical cabinets, the flexibility of having mobile connectivity, being able to use different protocols that weren't around previously, but now have kind of really sped up data sharing and easeability of use for a lot of the users.
Okay, great. All right, so what would you say are the key benefits that digital PLCs offered in comparison to traditional PLCs?
From my experience lately, especially with talking with small or medium companies that don't really have the resources, is having the ability to be easy to use and flexible, right? So a lot of engineers or even just a lot of just shop floor folks don't understand ladder logic, but maybe they'll understand something like C# that's being taught in like entry level courses. Having the flexibility of not just being able to code in ladder logic, but because it is a PC based PLC, you could code in languages like Python and C#. And then the GUIs, having more graphical user interface instead of hard code coding, and sharing that data like through protocols like MQTT, which has been huge for us. So that's what, one of the key differences is really the flexibility, ease to use, connectivity. Back in the day, you would have different modules, either gateways, Wi-Fi modules, if you really wanted to connect your PLC through Wi-Fi. Now, a lot of the times, these digital PLCs have the PC as like an edge computing capability within the hardware, has Wi-Fi chips enabled. All these protocols are built in. Makes it really easy to use.
All right. Ted?
Honestly, I don't have a whole lot to add to what he's saying there. I definitely agree that the flexibility of coding options is very important. Partly as he alluded to, just the nature of engineers entering the field, what they know, being able to code in different languages is going to be very important, for recruiting and just the vitality of the industry. Number two, just the wide variety of functions that we are trying to implement when we're doing industrial automation. When I first started in this industry a little bit longer ago than I'm going to mention in this interview, machine control was pretty much read sensors, turn on devices in response. You just do that over and over again. Now, one of the advantages of ladder logic, it does that sort of sequential operation very, very, very well. So, there is value to that. But on top of it now, the MQTT, OPC UA, the different types of functions we're being asked to implement. The other languages like Python, Node-RED are very useful for that. So having a digital PLC, I think, along with just being able to work with the knowledge that's out there with the trends, can effectively bring the two worlds together much more easily than you could in a conventional PLC. So you could let the latter do what it's best at, which is running a system repetitively, and then using the higher level languages for your networking, your controls, calculations, processing, that sort of thing.
So basically, how would you define a digital PLC and what distinguishes it from conventional? So you already touched on that a little bit, but maybe if you guys could delve into that a little deeper. Ted, I'll start with you on this one.
Conventional PLC was essentially the hardware and typically some kind of a proprietary OS, closed OS that, allowed you to do the machine control loop. A digital PLC, it's a lot more than that. It's an open OS, which it just gives you more options for programming control, functionality. The form factor can be completely different. We've both touched a little bit on HMIs, Ethernet switches, certain devices that are not the typical factor, and that's because it's digital, it's software, and the hardware is just more a platform that could be changed for running the code that you've developed. So a digital PLC being fundamentally software in many ways could make it more portable, so that you're not just stuck with this particular hardware platform. You could move it to this or run it on this, for instance, depending on your needs. Do you need more Ethernet capability or doing network control rather than local I/O? Well, maybe you could run it on an Ethernet switch or a router or some device like that, for instance.
Okay. What do you think, Eric?
Exactly. Really, Ted really hit it on the head. The software-centric portion of digital PLCs compared to, what traditional PLCs were, where you just had a CPU, maybe some kind of comms module for communications, either Ethernet or Wi-Fi, and then your basic IOs, right? Now you have in the CPUs, you have on-edge computing where you could run the software calculations, data visualization capabilities. So having HTML based dashboards that you could bring up on your mobile phone and actually control the systems using your either tablets or mobile phones, or even just a desktop located somewhere in an office setting where you don't have to have the HMI in front of you, but you don't have to have some crazy network infrastructure like additional gateways, PCs, where everything's built into the digital PLC itself.
So when you were talking, Ted, when you were talking about the virtual PLCs, and we were talking about how basically it's a piece of software is what it ends up being. Mm-hmm. So how are the updates to the virtual PLCs handled? How does that happen? Is this all on like a cloud-based platform? Is that how the virtual PLCs work? Or do you have to have it in a machine that's on site and then do the updates that way? Can you speak to that at all?
Yeah, I mean, there's a couple of different approaches to this right now. I can tell you that our approach anyway is the control engine would actually reside on the specific piece of hardware, kind of turning that into the PLC, but the program you craft, you could move it around depending on specific, specific functions you're trying to develop, so for us, it is on the piece of hardware. And then, I mean, we have a procedure where if you want to do a firmware update, it's just a download off the internet. You can put it on there. Our updates are usually free, so you can kind of keep it current that way. So that's how we're doing it right now. That could change over time. I have definitely, I know in the automotive industry, have talked to some companies who are keeping their virtual PLC up in a cloud somewhere, and then they don't have actual PLCs necessarily in the plant. They're more like, like remote smart units that are taking their commands. They may have some distributed intelligence in case you should lose your network connection. That can always be an issue whenever you're doing cloud-based control.
Mhm.
But I don't have a whole lot of details on how that's being implemented yet necessarily, but I have seen that as another path some companies are following.
Yeah, that's kind of the trend I've been seeing, as far as the virtual PLC being in the cloud and having just remote IOs, on site, on prem, doing the data collection, transferring it to the PLC. PLC does the logic, sends back the command to the output, and just overall having just the safety PLCs and overall safety logic on prem, just in case you do lose that connectivity, because safety's number one, right?
Mhm.
And The logic itself, usually, from what I've seen, really lives in a VM type environment, and all the code and everything is stored within that VM and easily accessible and modified and updated as well for safety and security packages or patches.